Okay, so in this video I'm going to have a look at question 5 from the sample paper Applied Maths Higher Level 22-23. Okay, so in question 5a here we have a network and the edges represent roads and the nodes represent the junctions of two or more roads. They're labelled with letters A to N and the weight of each edge represents the distance in kilometres between a pair of junctions. We've got to use Discra's algorithm to find the shortest path from junction A to N, and we've got to calculate the length of the shortest path. Relevant support work must be shown. Okay, so I've drawn up the network here where we can fill out the working values. So let's start. Now we're going to start with A here, the source node, and that's going to be labelled number 1, and it has a working value of 0. So the first thing we need to do here is go up to C. We can see that it will have a value of 12, and that comes from A. We can go out to D here, which is 25, and that comes from A. And we can come down here to B, which will have a working value of 17, and again that comes from A. So that's my first step. So the next step I need to do is to look for the lowest working value, and we can see that the lowest working value is here at C. So I'm going to call that number 2, and it will have a working value, a final working value of 12. Okay, so let's go from C out to the other nodes then. Let's go this direction first. So we've got 12 plus 23. So that'll give me a value here of 25, and that has come from C. Down along here, so let's go from C. So what I'm going to do is go out this direction first, and we can see that if we add 12 to 23, we'll get 35. That comes from C. We can come down along here to D. So we've got 12 plus 11. So that's 23. That's lower than 25. So I'm going to put that in here. 23. And that comes from C. And we can, well, that's it really. That's those two done. So let's look for the lowest working value so far. So we've got 35, we've got 23, and we've got 17. So 17 is what I'm going to use. So that's going to be my final working value here, and that's going to be number 3. Okay, so we need to go from B then, so let's do that. So if we go up along this direction here, we've got 17 plus 9, which is 26. But this already has a lower working value of 23, so I'm just going to leave that at 23. We come out this direction here, we've got 17 plus 10, which is 27. That comes from B, so I'll put that there. Okay, now let's look for the lowest working value. Let's see, we've got 35 here, we've got 23 here, and we've got 27 here. So 23 is the lowest. So that's going to be my final working value here, and that is number 4. So now we go from D. So let's go up this direction first. So you've got 23 plus 24, so that's 24, 34, 44, 47, but we already have 35 here, so we're not going to put that in. We've got 23 plus 8, so that's 31. So we can put that in here, so 31, and that comes from D. Down along this direction, we have 23 plus 14. That's 37, so that's going to be too big because we already have a lower working value here. Okay, so what's our lowest non-completed node then? We've got 27, we've got 31, we've got 35, so it's going to be 27 here. So that's going to be our final working value, and that's going to be number 5. Okay, so let's go from E then. If we go up along this direction here, we got 27 plus 12. That's 39, but we already have a working value of 31, so we're not going to put in the 39. If we go out this direction, we've got 27 plus 18. It's 45, so I'm going to put 45 out here. So 45 is going to go here, and that comes from E. Okay, so let's look at our non-completed nodes and see which one is the lowest. Well, we have 45, we've got 31, we've got 35. So it's going to be F, which is 31. So I'm going to put 31 here, and that's going to be number 6. Okay, so let's go out from F then. So from F we can go up along this direction here. So that's 31, 41, 51. So I can put a 51 here. And that is from F. And really that's it, I think. Yeah, that's it. So let's look at the lowest then. We've got 45 down at H. We've got 51 at I. And we've got 35. So our smallest one here is 35 up at G. So that's going to be our final working value up here, 35, and that is number 7. Okay, so let's go from G then. So we've got G out this direction here. So you've got to take 35, add 19, that's 54. And that comes from G. We can go down along this direction as well. So we've got 35 plus 15. That's 50. So that's lower than 51, so I'm going to include that. So that's 50, and that comes from G. Okay, that's it. So let's look at our uncompleted nodes then. We have 45 down here, we've got 50 here, and we've got 54. So our smallest one is 45, so that's going to be my final working value here, and that's number 8. Okay, so let's go from H then. So if we go out this direction first, we've got 45 plus 16. That's 61, and that's going to come from H. We've got 45 plus 17, so 45 plus 17 is 62. That's going to go here, and that's coming from H. And that's it really. We have this direction here as well. So we can go in this direction here as well. So we've got 45 plus 21. So that's 45, 55, 65, 66. But that's too big because we already have 50 there. So that's fine. Okay, so let's see what our smallest value is. We have 61, we have 62, and we have 54. So it's going to be 54. So 54 is going to be my final value here, and that's number 9. Okay, so let's look for our smallest working value. Let's see, we have 61, we have 62, we have 54, and we have 50. So 50 is my smallest working value, so that's going to be my final working value here, and that's number 9. Okay, so let's go from I then. So from I we can go up this direction, so that's 50, 62, so that's bigger than 54, so I'm not going to include that. We can go down along this direction here, that's 50, 63, again that's bigger than 62, so I'm not going to use that. And we can, let's see, we can go, well that's it really, we can't go in any other direction. So that's it. So let's find the smallest working value. We have 61, 62, and 54. So it's going to be 54. So our 54 is going to go up here, and that's number 10. Okay, so let's go from J then. Out this direction, we've got 54 plus 7, so that's 61. And that's come from J. We can go down along this direction here, so that's 54 plus 6, so that's 60. 60 is smaller than 62, so I'm going to include that, and that's from J. And we can't really go in any other direction, so that's it. So our smallest working value now, let's see, we have 61, 60, and 61, so it's going to be the 60 here, so that's going to be our final working value, and that's number 11. Okay, so let's go from L. So we go this direction, we've got 69, so that's bigger than 61, so I'm not going to include that. We've got out to our sync node. Let's see, that's 6072, so I'm going to write that down, and that's from L. Okay, and we can go this direction here as well, which is 64, but that's bigger than 61, so I'm not going to do anything with that. Okay, so our smallest working value now is 61 here and 61 here, so I have a choice. I'm going to go with this one up here, so I'm going to say 61 here, and that's number 12. Now going from M then down to our sync node, we've got 61 plus 14, so that's going to be bigger than 72, so I'm not going to include it. And that's it really. Our smallest value at this stage is 61, K here, so that's going to be our final working value here. So we have 12, and this is going to be 13 here. Going up here to the sync node then, we've got 61 plus 15, so that's 76. That's bigger than 72, so we don't include it. So our final working value in our sync node is going to be 72, and that's number 14. Okay, so that's the first part of this question. What else were we asked to do? Calculate the length of the shortest path. Okay, so the shortest path then, is shortest path length, I should say, is 72, and we're dealing in kilometers here. Let's see, calculate the length of the shortest path and find the shortest path. So the shortest path then, is, let's see, we start at, if we start at the back here, actually, at the sync node here, we've got N out here at the back, at the end, and we had to go to L, which was out this direction here. I'm just looking at this letter here, so the next letter back would be L. From L then we can see that we came from J here, which is, where's J? J is up in this direction here, so the next letter here is going to be J. And from J then we can see that we came from G, which is out along this way, so put G there. From G we can see that we came from C, so we're going to go, no, not that direction. Oh yeah, it is. We came from this direction here, C out in that direction, so it's going to be C. And then from C then we can see that we came from A here, so that's it. So our shortest path is ACGJL with a length of 72 kilometers. So that's it for part 1. Okay, so let's have a look at part 2 of this question. So let's see, we have a group of engineers want to close down some of the roads to carry out maintenance work. They wish to close down as much of the road network as possible while still allowing a person to drive between any two junctions on the network. Using an appropriate algorithm, find the minimum spanning tree for the network, name the algorithm you used. Relevant supporting work must be shown. Okay, so we've got 2 types of algorithms we can use here. We've got Prim's and Kruskal's, so I might just do both of those. I'll start with Prim's algorithm. So let's have a look at that. So I'm going to start here at A, and we'll draw from A to C. We'll go from A to C. So we're going to start here at A, and we'll go up here to C, because I'm looking for the minimum value for any arc going from A. So we've got 17, we've got 25 and 12, so I'm going to go with 12. So that's that one there. Next thing you do is you look for the minimum arc weight going from A and C. So let's see, from A and C we've got 17, 25, 11, 23. So it's going to be 11, so that goes down to D. So I'm going to draw that down to D, and that's 11. So now you've got to do the same thing again, look for the minimum weight from any of these nodes. So let's see, we have from A we have 17, we have 25, we have 23, from D we have 24, 8, 14 and 9. Now the smallest one there is 9, but just a point here that the smallest here is actually 8 from D to F. So what I'm going to do here is use that one, but just a note here, I mentioned 25 here, that actually goes back to A, and what that will do is will cause a cycle, so we can't include that anyway. I'm not allowed to use any cycles when creating this minimum spanning tree. So I'm going to go from D out to F, and that gave me 8. Now going from all of these nodes, what's the minimum value? Well, the minimum value that I can see there is actually 9, going from D, so that's going to go down this way. That goes to B, so that's 9. Now looking at all the values going from all these nodes, let's see, from C we have 23, from D we have 24, we have already got the 8, we have 14 going down to E, we have 9 going from B, going down to B, but we've already done that one, and we've D to A, which will cause a cycle, so we don't include that one. Okay, so the smallest one then that we have, well actually we have going from B here, we've got 10 as well. So the smallest one is actually going to be 10. So let's go with 10 from B, so we're going to go down this way to E, and that has a weight of 10. Okay, so let's continue on. Let's see, from E then we have 12, which will bring us up to F, but that'll cause a cycle. We've got 18 coming out here. From F we've got 20. We already have the 8. From D we've got 24. From C we've got 23. I think that's all of them, but the smallest one there anyway is 18. So I'm going to go out to H with a weight or a distance, I think in this case, of 18. Okay, so let's continue on from H then. Well, actually from E we've got I, which is up as far as I, which is 21. From H we've got 17 and 16. From F we have 20. From D we've got 24. From C we've got 23. I think that might be all of them. The smallest one anyway is 16. So that goes out to K. So I'm going from H, which is here, out to K, and that has a weight of 16. Okay, again, let's see, we have K now, so we have 15 and 4. I imagine the 4 is going to be the smallest. Let's see, all the other ones are bigger than 10, yeah, so it's going to be that 4. So that goes from K up to L, and that has a weight of 4. Okay, from L then, okay, from L we have 12, 9, 6, we have 13 out to I, we have 17 back to H, but that's a cycle, so we can't use that. From C we've got 23, from F we have 20, from H we have 21, we have 17, but that'll make a cycle. I think I have all of those. Now the minimum what I can see there is 6, and that goes to J. So from L up to J. So let's do that. So we're going up here to J, and that has a weight of 6. Okay, so again from L here we have 12, we have 9, 6 we've just done. From J we have 7, we have 19. Back to I we have 12. From K we have 4, which we've done, and we have 15 going out there. Let's see, from H we've got 17 to L, but that will cause a cycle. We have 21 up to I. From F we've got 20 out to I. We have this one up here, and we have D as well. And we have, I think that might be all of them. Let's see, oh no, we have this one here, 13. And I think that might be all of them. Let's see, what's the smallest one that we've got there? Looks like it is 7, and that's from J to M. So let's draw in that one. So we have J down to M, and that's 7. So let's go again. We have 14, we've got L out to N, which is 12. We have L up to J, we have L up to I here, which is 13. We have this one again. We have F up to I. And let's see, we have L to M will cause a cycle, so we can't use that one. And I think that might be it. H up to I, we've got 21. H to L will cause a cycle. I think that may be it. So our next one will be... So we also have J to I here, which is 12. So I think that may be our next one then, 12 from J to I. So let's put that one in. So from J to I, this is I here, and that's 12. Okay, we've almost got all of the nodes at this stage. So let's see, we've got 15 up to here, we've got 19, we've got 23, we've got 24, and I think the rest will cause cycles. So really what we're going to do next is go out to G, from I to G, so that's 15. And that will bring G into play then. So we've got G up here, and that's 15. Okay, and then finally the only node we haven't included is this one here, this N out here, so let's just include that one, 12 out as far as N. And that's it, that's our minimum spanning tree. Now if you add all of these up, all these weights up here, you get a total distance of 140 kilometers. Okay, so that's our minimum spanning tree using Prim's algorithm. Let's have a look at Kruskal's algorithm here. Now, in order to do Kruskal's algorithm, you need to list all the arcs in ascending order, so of weights. So in order to use Kruskal's algorithm, you need to list all the arcs, or all the length. So in order to use Kruskal's algorithm, you need to list all the arcs or the lengths in ascending order of distance in this case. So I've already done that in this list here. So you then start with the smallest one. The smallest one here is KL. So I'll just have a look at the original diagram at the same time so that I can draw this. Okay, so we're starting with KL here, so from K to L is this arc here, from K to L, so I'll just draw that over here, so K to L, and that's 4, so we've done that one. J to L then, so J to L is down along here, and that's 6, so I'll draw that one, so that's J, and that's 6, so I've done K to L, and I've done J to L. Now J to M then is 7, so let's do that one. J to M, which is 7, which is this one here, so I'll just draw that one in. J to M, and that's 7. D to F, so D to F is along here, so I'll draw that one, let's say here, D to F, and that's 8. Next one is B to D, so B to D will come up along here, and that's 9 kilometers. So B to D, so that comes up along here, B to D, and that is 9. Okay, so the next one then is L to M. So let's find L and M. Okay, so if we do L to M, we'll do this here, we'll end up here. Now the problem with that is it causes a cycle, so we don't include that one. Next one is B to E. So B to E comes down along here, and that's 10, so we'll include that one. So B to E, 10. Next one then is C to D. C to D comes down along here, so we can do that one, B to D. C to D, I should say. C to D is 11. A to C is the next one. A to C is this one here. Let's put that one in, A to C, and that is 12. Okay, so A to C. IJ is the next one. Let's have a look at that one. I to J is this one here. So I will be around here somewhere, and we're going up to J, and that is 12. This is I here. Okay, let's see, where are we? I to J. L to N is next. L to N. So let's see, L to N is out along here. And that's 12, so that'll bring us back to our sync node, and that has a distance of 12 kilometers. Next one then, E to F. We have E to F here, goes from here to here. The problem with that is it causes a cycle, so we don't include that one. E to F is the next one, so we have E to F here. I to L is the next one, so I to L is from here to here. Now again, that's going to cause a cycle around here, so we can't use that one. So I to L, can't use that one. Next one is D to E. So D is here and E is down here. Again, that's going to cause a cycle here, so we can't use that one either. M to N is the next one. M to N, again, that's going to cause a cycle around here, so we can't use that one. G to I, let's have a look. G to I is here. Okay, we can use that one, that's 19. G to I, so there's a G here and an I, let's say here. So that's G. So G to I we can use. G is up here, and that goes down to I, and that has a weight of 15. Okay, so G to I we can use. G will be here, and I is down here. So we'll join that up, and that has a distance of 15. Okay, so G to I. K to N is the next one. So we have K out here, and we want to bring that up to N, so that would be up along here. So again, you can see that's going to cause a cycle, so we don't include that one. H to K is the next one, so H to K is along here. We can do that one, so H is here, K is here, and that has a distance of 16 kilometers. And what have we got? H to L then. H to L will bring us along this way. That's going to cause a cycle, so we can't use that one. So we can't use that one, so that's out. So A to B is the next one. A to B will cause a cycle as well down along here, so that's no good. E to H, let's see, E to H we can do, that's along here. So E to H doesn't cause a cycle, and that has a distance of 18. I think we're kind of finished at that stage. Let's see, we have E to H. G to H is going to cause a cycle. F to I will cause a cycle. H to I will cause a cycle. C to G will cause a cycle. D to G will cause a cycle. and A to D will cause a cycle. So really that's it. So none of these ones here we can actually use. Okay, so that's it really. I mean, we have our minimum spanning tree there, and you can see it's actually the same as the one we got when we did Prim's algorithm over here. And if you add up those distances again, of course, you'll also get 140 kilometers. Okay, so let's move on to the next part of the question. So in part B here we have a rumour which may be spread when a person who has heard the rumour interacts with a person who has not heard the rumour. Therefore, the rate of spread of the rumour within a group can be modelled as being proportional to the product of the number of people in the group who have heard the rumour and the number of people in the group who have not heard it. A student models the rate at which a certain rumour spreads within a school population of 1,200 students using the differential equation d r dt, where r of t is the number of students of that school who have heard the rumour at time t, measured in days, and where k is a positive constant. So on Monday morning, t is equal to 0, 100 students had heard the rumour. Solve the differential equation to find an expression that relates rk and t. Now we're given this equation here as well. Presumably we're going to have to use that at some stage. And this can actually be derived using partial fractions. I'm not going to do it in the question, but I do have a separate video on partial fractions if you want to look at that. So let's start it anyway. We have dr dt, so we have dr dt is equal to k times r 1200 minus r. So what I'm going to do is just separate out the dt and the r's. So I'm going to put the r's on the left hand side and the dt on the right hand side, and along with the k. So on the left hand side I'll end up with 1 minus r times 1200 minus r. On the right hand side I'll end up with k dt. Now, by the way, I have a dr here as well on this side. So let's just take this here and use this to change the way it looks. So we have 1 over, this is going to be my y, 1200 is going to be the x. So let's just write it in that format. So we've got 1 over the x, which is 1200, times 1 over r, plus 1 over 1200 minus r. That's dr, and that's equal to k times k dt there, if you like. Okay, let's just multiply this out. So you've got 1 over 1200 r plus 1 over 1200 times 1200 minus r dr, and that's equal to k dt. So let's integrate the left hand side and the right hand side. So what we need to do is put in our limits as well. So we have all r's on the left hand side and t, time, on the right hand side. So initially 100 people had heard the rumour, and we're going to go up as far as r. On the right hand side, time starts at 0, and we're going to go up as far as t. So we're going to integrate k dt on the right hand side, on the left hand side this expression here. So 1 over 1200 r plus 1 over 1200 times 1200 minus r with respect to r. Okay, so let's do the integration. So on the left hand side we have 1 over 1200 anyway, and then 1 over r just becomes log r. Now here we've also got 1 over 1200, and it's going to be log 1200 minus r, but really we need to put in a minus as well here because of this here. Because if you differentiate this, if you work backwards, you'll end up with a minus, so you want to put a minus in here as well, so that you will end up with this plus here. Okay, so we want to integrate between 100 and r, and on the right hand side then we have k with respect to t, so that's just going to become kt, and our limits are 0 to t. Okay, so let's go again. Now let's just put in the limits then. So we have 1 over 1200 log or minus 1 over 1200 log 1200 minus or minus, now we've got to put in 100. So it's 1 over 1200 log 100 minus 1 over 1200 log 1200 minus 100. Maybe I'll just put that in as 1100 here. And that's equal to k times t. Now if I put in t here, I'll just get k times t. If I put in 0 here, I'll just get 0. So really that just becomes k times t. Okay, so let's just factorize out the 1 over 1200 first. And if we look at this here, we're just left with log or minus log 1200 minus or. So that's just going to be log or divided by 1200 minus or. Now over here, factorize out the 1 over 1200 as well out to here, and you're left with a minus. Also, you've got log 100 over 1100, and that's equal to kt. Okay, so the next step then is just to look at what's in here. So we leave this out here, 1 over 1200. And this is just going to become log of this divided by this. So I'm just going to flip this upside down and multiply. So it is 1100 or over 100 times 1200 minus or. And that's equal to kt. So the next thing I'm going to do is I'm going to divide the 100 in here, and I'm also going to multiply both sides by 1200. So on the left hand side I get log 11 or over 1200 minus or. On the right hand side I get 1200 kt. Okay, so really I think that's about it. I mean, we can keep going, but really the question asked us to solve the differential equation to find an expression that relates or k and t. I mean, we could keep going and write e to the power of 1200 kt is equal to 11 or over 1200 minus or. Then let's see, what could we do? We could divide the top and the bottom by or, and so on and just reduce it down to 1 or and get or in terms of kt. But maybe we'll just stop there. I mean, we can keep going forever here really. So that's it for this part of the question. Okay, so let's look at the next question then. We have, let's see, by Wednesday morning 250 students had heard the rumour. Calculate the value of k. So we know that Monday morning is t0, so that's Monday morning. T1 then is going to be Tuesday morning, and T2 then is going to be Wednesday morning. So really we're looking at a t of 2. So let's stick that into our formula. Remember, our formula from the previous question is log 11 or over 1200 minus or, and that's equal to 1200 kt. So we have log 11 times 250 divided by 1200 minus 250. And that's 1200 times k and times 2. So look, you just do a little bit of manipulation there and you'll find that k is 4.4287 by 10 to the power minus 4. And that's really it for that part of the question. Let's have a look at the next part then. We have to sketch the shape of the graph of or against t to show how the model predicts the spread of the rumour. Okay, so I've kind of done this already. All I've really done is taken different values for t, and I'm just going to plot those. So I've taken t is equal to 5, t is equal to 10, t is equal to 20, and t is equal to 30. And I got a value there of 1200. So you can see at T20 we have almost 1200, so it levels off basically. So let's just plot a few of them anyway. So we know at the beginning T0 that R is 100. We were told that in the question. For 5 we got 677, so we can come up along here to 600, that's 700, so it's around here somewhere. T10 then is 1138, so let's go up along here to 1138, so that's somewhere around here. And then T20, I've got 1200 effectively, so T20 is going to be just underneath the line here, and then T30 is going to be here. So it comes up along here and levels off. Oops, gone a little bit high there, but you get the idea. And that's really it for this question.